C++ succeeded, not so much because I made a beautiful design, but because I was really lucky of having identified a problem that a lot of people were about to get.
Bjarne Stroustrup grew up in Aarhus, Denmark. With a talent for math, he decided to study computer science at the local college.
The word computer is not in the title of that in Danish. So I was quite capable of misunderstanding it and thinking it was math. And in my second year I realized that I'd been wrong, and programming, data structures, machine architectures is not math. At least not at that level. On the other hand, programming was really fun, and learning about machines and computer science in general was really fun, and haven't looked back since.
In grad school, Stroustrup gained insight working as a contract programmer, dealing directly with clients.
If I could build a demo that the client was willing to pay for, then I got the job of implementing the system. And I have a fairly strong opinion about systems being appropriate and reliable and affordable, which I think partly came out of that.
Stroustrup earned a PhD at Cambridge, where his advisors included computer legends Maurice Wilkes, Roger Needham, and David Wheeler.
And you come in, a new grad student, you're full of great ideas, right? You come in and you're explaining these great ideas to David Wheeler. And he sits there and he sits thoughtfully. Yeah, Bjarne, that's not a bad idea. You know, we almost did that for the ETSAC 2, which was the most dreaded words, because that means that in about 56, about the time I entered primary schools, they've thought of it. I wrote a simulator and I brought the university mainframe to its knees before I could get any decent data out of it. The resource demands of that simulator was just too much for the mainframe. But when you do this as a grad student, you only do it about once before you're kicked off the machine, because the astrophysicists and the chemists have much better funding, financing, and political power. And I got my data and I got my PhD, and I came away with the opinion that I would never again want to attack a problem with tools that was fundamentally unsuitable. I don't want to make the choice between elegant, which simulator was for this problem, and efficient, which BCPL was. I want both. And that has been sort of one of my guiding lights. If you give people the choice of writing good code or fast code, there's something wrong. Good code should be fast.
At Bell Labs, Stroustrup developed C++, an object-oriented programming language that made abstraction techniques affordable and scalable.
In October '85, we had a commercial release, which was known as the brown bag release, because it was so cheap, and because it has been so economical building it. I wrote 98% of everything there. Documentation, build procedures, testing, language, the works.
C++ revolutionized the industry, and after 3 decades, it's still the language of choice for a long list of users.
C++ survives for this kind of stuff because there are things like the video cards and the graphics, the networking software. All of this kind of stuff that's at the bottom of every system has to be efficient. And is there a solution that can help a broader spectrum or a larger group of people, larger set of problems, larger time scale? But we have to find the problem first that's worth solving, and find the constraints on the solution to the problem. After that, we have pretty good ways of engineering a solution. My advisor was a fellow and his advisor was a fellow. Being recognized to be part of all of this is very, very exciting for me, and I'm very honored.